Okay, Assalamualaikum and hi guys. So today I would like to explain further on the example 10.4. Some of you have been asking me to re-explain on this example. So this example is actually you want to calculate the chemical composition. Okay, so in the end, okay, so first continuation from the previous example, they give you the component and also the wet mass. Then you find out the moisture content from the dry mass, right? So previously we get something, the moisture is 21 or 20.9. All right, so this is the dry mass 74.1, and then this also were given in the question, the composition of the in the waste sample, so based on CHO and S. So in the end, what we want a chemical formula to describe the waste sample, right? Okay, so in the end you will get an equation something like this. Okay, all right, CHO and S. All right, so let's have a look on the solution, right? So the first thing you need to do is you total up this, okay, the ash, sulfur, and others lah. So you calculate the dry mass. So dry mass normally is not be given to you from the previous example. Okay, right, so you can calculate the dry mass using the wet mass and the formula for moisture content. So total up here is 74.1. Okay, and then you prepare this table. All right, so you listed out all the composition. So moisture, carbon, hydrogen, oxygen, nitrogen, sulfur, ash. Okay, you fill up those without oxygen or hydrogen first. So like ash, so you take directly. So you see ash here is 4.47, so you insert into this table, right? You do the rest, you do the same thing for the rest except for the one that involve moisture. So moisture in this, you have calculated it before that you get 20.9 or 21%, right? So moisture contains hydrogen and also oxygen, so it will affect your hydrogen content and also oxygen, right? So initially you see hydrogen is 4.58, right? So 4.58, and then your oxygen is 30, right? 30. So the next one is to convert the moisture content, because we want to in the end giving it the composition in terms of CHO and S. So you need to convert everything become the composition. So hydrogen, so you know hydrogen have in water you have 2H over 18. This is 18, right? So let me close up a bit. Okay, oops, right. So let me show you. Right, so you can see here this is 20.9. okay, 20.9 comes from the moisture. Okay, and then oxygen 20.9. Oxygen only you have okay, you have one oxygen, so 16. This is molecular weight. This is hydrogen 2 times 1, right? So you get the mass in kilogram. So if not given how many the waste, you can always assume 100 kilogram. All right, so the next step is preparing, okay, this table. All right, sorry, so preparing this table. Okay, so where you total up the amount of hydrogen just now and also oxygen, right? So if you compare, the amount of hydrogen have increased, right, and also oxygen. Then you compute the molar composition. So now you convert the mass into molar. So you are using what? Your chemistry is important here. So mole is equals to mass over molecular weight. So this is your mass, this is your moles. So you have carbon 12. So using this formula, and then you will get this value, right? And then the next one, Okay, so you want it to be in the end sulfur is equals to 1. So that's why dividing everything with sulfur. So sulfur, the most of sulfur here is 0.004. So later, what you will do is, you see here, is actually 2.873 divided by 0.04. So 2.873 divided by 0.04. Okay, so you will get this value. You do the same for the rest. So sulfur, you will get 1, right? So you do the same thing with nitrogen. So you make it, the nitrogen become 1. So everything must divided by nitrogen is 0.031. So you get this column. So the chemical formula with sulfur, you take the value from here and you get this formula. While chemical without sulfur, why without sulfur? Because here sulfur is 0. So this is the formula, right? So the next page is actually calculating. Okay, so let me show you. So this page is actually estimate the energy content. Okay, so this is the equation from the formula. Okay, formula you may refer. This formula 10.4. So you have calculated CHONS. So you insert into the formula to get this energy that you can gain, energy content from the waste, right? So in the next video, I'm going to show you on how from this equation, okay, you can estimate how much is oxygen required for aerobic process or anaerobic process. Or an anaerobic process, you don't need oxygen. You will need to know how much ammonia is produced. Okay, so that topic is actually in the textbook and also in your I think it's in your lecture note that I've given to you. So it's actually explaining, for example, 12.1. Okay, but I'm telling you, the question may related to each other, right? Okay, so I stop here and I'll continue with example 12.1.